7.6, the inverse of a square matrix. What you should learn. Verify that two matrices are inverse of each other. Use Gauss-Jordan elimination to find inverses. Use a formula to find inverse of a 2x2. And then how to use matrices to solve system linear equations. So the inverse of a matrix works like any inverse does. When you talk about an inverse of a number, in multiplication, that's reciprocal because they cancel each other out and you get the identity. It's been the same thing with matrices. If I give you a matrix and I multiply by its inverse, I should get the identity matrix, which is a matrix where the diagonal of 1 and everything else is 0. So something like this. We talked about it a little bit in a previous lesson. Right, or like that, and so on. So two matrices are inverse to each other. If when you multiply them, you get this, what we call the identity matrix. So first, let's show these two inverses let's show that B is the inverse of A. So when we multiply them, we should get an inverse identity matrix. So remember the way we multiply? The shortcut is probably, I think the easiest way to multiply is put the second one toward the top, like this, and then you split it, right? This is a 2x2, and multiplies and you get a 2x2. So I could do it right away, right? All we're gonna do is multiply the first two elements, and you get -1, plus the next two elements, 2. So I get 1. Same thing here, multiply the first two, I get 2, plus the next two, -2, and I get 0. Multiply the first two, -1, plus 1, so I get 0. And then -2 plus 1, -1. This one should not be negative. I messed that up. Okay, 2 minus 1. There we go. So 1. That was not working for a second. I realized my mistake. So 1, 0, 0, 1. That is a matrix. So that's how you can know if two matrices are inverse to each other. Now they have to be a square matrix. Square matrix, this means it looks like a square. It's an m by m. Like here we have a 2x2, or a 3x3, or a 4x4. So only those type of matrices have an inverse. And that's one way to tell. Two things are inverse to each other, multiply them, you should get 1, 0, 0, 1. How do you find an inverse? A lot more work. So the proper way to find an inverse is what you do is, if we want to try to find the inverse of this guy, is you write it as a big augmented matrix. You write, on one side you have the matrix that you're trying to find the inverse of, on the other side you have the identity matrix. And what you have to do is make the left side into the identity matrix. Oops. Right? So you got to make the left side turn into this side. And whatever's on this side will be your inverse. So you have to do elementary operations to make this side look like that side. So let's try it. So first, I want to try to make this guy a 0. So let's go, this is row 1 and row 2. Let's go row 1 plus row 2, then add it, make that my new row 2. So I'm going to keep row 1 the same. Right? And then we're just going to add down these two rows. So 1 plus 1 is 0. So you can see what I'm doing, 0. 4 plus -3 is 1. And you also got to do the same thing here. 1 plus 0 is 1. And then 0 plus 1 is 1. Just like that. Next, so that part's done. I want to get rid of this 4 here. So what we're going to do is I'm going to multiply row 2 by -4 and add it to row 1. And that'll make my new row 1. So let's try that. Right, because I'm trying to make this guy into a 0. So we're going to do -4 times row 2 plus row 1. I'll make that my new row 1. So first let's rewrite the thing we're not changing. We're not changing, oops, sorry, too big. We're not changing row 2. I'm going to keep it the way it is. And then let's do the thing I said here. So we're going to multiply row 2 by -4, so 0, -4, -4, and -4. Then we're going to add them up and make that my new row 1. So 1 plus 0 is 1. 4 plus -4 is 0. 1 plus -4 is -3. And then -4 plus 0 is -4. And this guy is my inverse. So that's -3, -4, 1, and 1. Now if we want to check if this is actually the inverse, we could multiply them, right? So if I multiply my A times my inverse, I should get the identity matrix, 1, 0, 0, 1. And actually we're going to do that, but let's do it A inverse times A. Just to show you it doesn't matter which way you multiply them, you should still get the same thing. So we're going to do A inverse first. Then we'll multiply our A, our original A, which is 1, 4, negative 1, negative 3. Like that. Let's multiply these two. Right, so multiply the first two. 1 times negative 3 is negative 3 plus 4, so that's 1. Then we have 4 times negative 3 is negative 12 plus negative 3 times 4 is 12, so you get 0. Down here we're going to get 1 times 1 plus negative 1 times 1, so 0. And then we're going to get 4 minus 3, which is 1. So we do get the identity, 0, 1. So they are inverses. So that is one way to do it. It's a lot of work though. So luckily for 2x2s, we actually have a formula for it. The formula is this right here. This is the formula I would give you. It is, if you want to find it, if you say A is A, B, C, D, the formula for the inverse is 1 over, we're going to multiply this diagonal, AD, minus this diagonal, BC. We actually have a name for this, but we're going to learn that later. Then over here, we're going to switch this diagonal, and we're going to negate this diagonal. So this one gets switched. This one gets negated. And that's the formula. So again, it's something I would give you. You don't have to memorize it, but it's something you know how to use it. So it's possible to find the inverse of each one. Now, why does it say if possible? Well, if this right here is a 0, that means you can't divide by 0, so that means it's not possible. So if you do this first part, you get a 0, not possible. So remember the formula is, let's write it down. Copy, paste. So there we go. So let's find the inverse of this one. So let's say this is A, B, C, D. So our inverse is going to be 1 over down diagonal, so 3 times 2 is 6, minus up diagonal, negative 2 times 1. Negative 1 is 2. Then over here, we're going to switch these two, 3 and 2, the down diagonal, we switch them. And then we change the signs on these two. So they become positive in this case. So we get 1 over 4 times 2, 1, 2, 3, and then we distribute all the way out. So what, 2/4, 1/4, 2/4, 3/4. And that's my inverse. I mean, I could reduce 2/4 and 2/4 to 1/2. So let's just do that real quick. Make me feel better about myself. And there we go. That's the inverse of A. Again, we can multiply them and try it, but check one for it. This one here, right, A, B, C, D. So downward diagonal 6 minus upward, which is also 6. Now I could do the rest, but I already know that's a 0, right? And you cannot divide by 0. So this is called a singular matrix. So no inverse. Singular matrix. All you have to write is no inverse. So there we go with that. And so how do we find the inverse of a 3x3? Well, by hand, you have to do the whole process. There's no formula for it. If you want to find the inverse of anything bigger than a 2x2, I don't care if it's a 3x3, a 4x4, a 7x7, you have to do the same process we do for the original time we did a 2x2. Now, we're not going to do that. And you don't have to do that. You don't have to do that in class. What we're going to do is use a calculator. So that's how we're going to find the inverse of a 3x3 or anything higher is use a calculator. So all we're going to do is go to our matrix, the second matrix. We're going to type it in. So this one is a 3x3. Let's type in all the values. So 1, negative 1, 0, 1, 0, negative 1, 6, negative 2, and negative 3. Okay, we're going to get out, select our matrix, the second matrix, and all you do is press the inverse button. We actually have an inverse on this calculator. It is right here, negative 1 power. You press enter, and it gives you the inverse. And that's actually a nice one. Most of the time, it won't be this pretty, but that's our inverse. A lot of times you get decimals, and you have to make sure that it's much easier if you press afterwards, you press math and then fraction. Things like that. Actually, to show you, well, first, let's write down our answer. Come on, so our inverse here using the calculator, we're going to use technology, is negative 2, negative 3, 1, negative 3, negative 3, 1, negative 2, negative 4, 1. Like that. So let me show you. Let's do the first one, right? This is 2 by 2. Let's do a matrix on that one. So over here, we'll do a matrix B, and we'll make that a 2 by 2. And that's 3, negative 1, negative 2, and 2. Okay, so select our matrix, matrix B, and press the inverse button. In this case, we get a decimal. Now, that's not a bad decimal. Sometimes you get much worse decimals. So how do you make that a fraction? You go to press math, fractions number 1, press enter, and it'll make it a fraction for you. It's usually a lot easier to see. Okay, so that's how you find the inverse of a matrix that's higher than 2 by 2. You do this if you want to do it properly, or use a calculator. So let's talk about how to solve a system of equations. Okay, so the general idea is this. Let's say we give the form of an equation that 3x equals 24. The way we solve this, everybody goes, yeah, you divide by 3, right? Technically, what we're supposed to do is multiply the left side by the reciprocal of 3. Right, multiply by its reciprocal. This creates an identity, 1. And you get 1x equals 8. We're going to do the same thing for matrices. I'm going to give you matrix A times identity matrix X equals B. And what we're going to do is, we're going to find the inverse of A, and we're going to multiply both sides by the inverse of A. It has to be the left side, though. Remember, matrix multiplication is not commutative. Over here, put 1 third on this side, totally fine. In matrices, remember, A times B does not equal B times A, so you have to make sure they're both on the left-hand side. These will cancel, give you the identity, and you have this. So that's the idea of how to use matrix, how do you use the equations with matrices to solve. So let's do one real quick. So this one here, we're going to write it as a big old matrix, 2, 3, 1, 3, 3, 1, 2, 4, 1. And then this is the mirror x, y, z. Then we have what we call our solution matrix. Our constant matrix, sorry. Not solutions, our constant. So that's our thing. So this is our matrix A. This is our variables x. And then this is b. Now, we're just going to use a calculator to do this. So we're going to type it all in. I'll save you from watching me type it in. So enter them in. There's my 3 by 3 my A. And then here's my 3 by 1 B. So all we're going to do, all we have to do is solve it like we normally would. Multiply this by A inverse. A inverse. These will cancel. X equals A inverse times B. And that would give us our solution. So let's do it here. So I'm going to do A. I'm going to do its inverse. Then I'm going to times it by matrix B. And we get our matrix x, y, z is equal to 2, negative 1, negative 2. And that'll be our answer. So there you go. So that's how you use matrices to solve this using the equation of matrices. Honestly though, I think it's just a lot easier to do REF, make it a big augmented matrix. If I went up here, I got my 3 by 3 matrix. I change that to a 3 by 4 matrix. Right, and then added the solution here to all of them. So this is negative 1, 1, and negative 2. Like, we just have to solve a system of equations. For me, this is my go-to. Right, I go math, I go reduce row echelon form like we did in the previous lesson. Then I select my matrix. And I get the exact same answer, but for me it's a little faster. So that's the way I would do it. Anyway, that's the lesson.